Okay. Right, folks, so unit testing. Dive straight in. Unit tests are good. Hopefully I don't have to convince people of that. The particular use case I had for this was with BLE-OTS. So that was it's a feature we've been working on at work. Specifically, I need to navigate the file system. I need to recursively descend through all the files in the file system and then filter them out in a certain way. And I'm turning around. Oh, right. Sorry. No. Hold that thought. I hope I put it there. Okay. Somewhere. Put it there. Okay. Okay. Right. So yes, unit tests are good. That's the main takeaway from this slide. But because I need to navigate the file system. Why is it not? Sorry. I might have shared the. Sorry. Please say that's working. All right. Hit my rhythm. Okay. So the specific scenario was that I had files to navigate, and I wanted to unit test that. And I didn't want to have the unit tests interact with the file system, so I wanted to mock those calls out so that I returned like a list of files that I provided within my unit test. That was kind of the guts of the idea. Now, MicroPython doesn't have all the same features as CPython in this space. It doesn't have unit test mock. And even MicroPython lib's unit test module, it's rich in some areas. It's got really good support for assertions, but it doesn't have good support for discovery or for even just passing in a module that you want tested. It doesn't work very well like that. So there's a few efficiencies there. A couple other things to think about was, do we want to execute this on hardware? Well, I didn't in this particular case. It's often slower to deploy to the hardware to run your unit tests. It's often overkill. Like in this case, I'm just navigating a file system. The hardware itself, I don't really care about. It's always good to test in the hardware as well. In this case, it made more sense to run a Unix port. It's actually a really common thing to do, I think. So worth looking at. If you do have to run on hardware, we'll talk about that perhaps another time. But MP Remote makes that a lot easier, so I'm really excited about that. Now, we want to run the Unix port, but I don't really want to build it all the time. So how can we avoid that? Look at that. And the Unix port doesn't have everything as well. It doesn't have a machine module, doesn't have Bluetooth, because they're not supported in the Unix port. So we need to simulate those things, at least stub them out so that they don't do anything useful. See you, Sion. The other way to do this is we could execute it from CPython, regular CPython, and pass our MicroPython code to CPython, and then we can use things like PyTest, which is great, gives us a really rich unit test environment. There are differences. They're documented, a lot of them are documented. But I find running it under the Unix port's much closer because you can use the exact same interpreter, the exact same system that you would on the hardware. So we can use Docker to provide the MicroPython Unix port interpreter. That way we don't have to build the Unix port all the time. I'll show you that in a sec. We've also got some simulation code to stub out the modules like Bluetooth and machine that some of the libraries that I'm going to be putting in unit tests expect to be able to find. We're going to use an improved version of unit test. Andrew, good friend Andrew here, has put a bit of effort into making a unit test, some unit test improvements. In particular, this let me pass in a module to be tested. Now, we don't have a full mocking library, but we can monkey patch, which is just standard Python, where we can import a module and pretend it's another one by assigning it to the module name of the one we're expecting to find. Pretty straightforward. straightforward stuff. Nice tip there, thanks, Danny. And part of this needs some glue about configuring sys.path appropriately, so it finds the bits and pieces that we have in place here. And then there's a warning here because this didn't work for me. Originally, it caused me a bit of grief because it looked like when I was importing sys, nothing was working at all. It turns out it's really common to have a sys folder in the root of your Linux repository, which is the default working directory for a Docker container. And so that was getting in the way. It was finding the sys folder on Linux, finding no Python code in there, and not looking at the sys internal module. So there's a bit of a gotcha for you. We'll get to that in a sec. I'll go straight to a demo. Actually, we'll go. Okay, there's a long line of code there. But the upshot is that it's running tests and it's run those tests. So it's really quick to do. If we break down this line of code, can everyone see this? It's more now. Let's try. Do this. Some key combination here will increase the size of text. I don't know what. Anyway, no, can't remember. In any case, we're just spinning up a Docker container. I'll talk about that in a moment because I have built this container. There's a repository you can go download and build it yourself if you like. But I think we'd like to push this upstream at some point. I'll put that. Sorry, to put you on the spot, but I think we should probably do that at some point. Or at least make this repository official so you should never have to build this yourself. You can then just go to download this from the Docker Hub. And on that note, we've applied for MicroPython, the MicroPython URL in Docker Hub. Haven't heard back from Docker yet, but ideally you'd be able to just spin up a container that you can find on the Docker Hub. Getting a few blank looks, is that because people haven't used Docker before, or everyone's used Docker? No? Come talk to me if you haven't, but it's a way to spin up a container, which is like a little virtual environment to run inside. The other parts that are important here are passing in the code that we need. So these are volume mounts into the Docker container, and telling you that we want to start in a particular place. And then we inject a little bit of code, and that code is really to set up the paths that we need, and then to run the unit tests. And that is about it. So that hangs together nicely. I'm able to iterate on this really quickly. The unit test code is exactly what you would write in CPython. This ticks a lot of boxes for me. I mentioned last month that Mitchell Curry has been maintaining these Docker images. That's what I use to start my repository. I use that as a base. His weren't using the dev variant of the Unix port, which we need for async IO, which I needed for my images. Otherwise, you can use Mitchell's Docker containers. It's no problem. I should point out, like, you can just descend straight into a MicroPython prompt, and this is just regular Unix port of MicroPython. A really nice. I'm getting ahead of myself. So yeah, I used his Docker files to build my Docker images. So this is a good working solution, but I think there's a little bit more work to do to make this usable for everyone. So we should be publishing these Docker containers. We can also publish them with tags, and that'll allow us to go to any version. So if I want to test with 1.14 or 1.15, we do that very easily. The other thing is we need these stubs for simulation. I haven't shown you here, but there's some code that just needs to be in place so that when machine gets called by some of this code, it just does nothing. There's a tool called MicroPython, which we've covered before, which allows you to manage those stubs. Again, it would mean that you don't have to have these in your repository. You just have it as a dependency to say, hey, go grab me the stubs that I need. Most of that is that you'll get IntelliSense in VS Code if that's the tool that you use. And just to wrap up, we want to update MicroPython lib at some point. So we need there's a couple of different libraries that Andrew and there's actually a couple other online that look like they'll backfill some of the unit test features that we need. Maybe at some point we could look at doing unit test.mock as well. That would be very helpful in this case. It would mean we didn't have to do the monkey patching. And also, Damien went and had a look. Apparently, CPython, correct me if I'm wrong here, but apparently CPython, when you do an import sys, it explicitly deprioritizes the file system lookup, so that we can't run into that problem there. It'll look for the folder first.
Yeah, there was something there.
Yeah, so that would get around that problem there. Yeah. Yeah, there's just a few things that sort of came together to make this work. This is really super useful for me, so sort of share it with you. Hopefully it was useful. If you got any questions, come talk to me. It's a bit in there. That was it. I'll stop talking.